with liquid oxygen and hydrogen propellant 5 hours ago. We are now reaching 15 minutes before ignition, and all the elements being checked to see if ready for the synchronized sequence. And here is a close-up view of the Vulcain 2.1 engine nozzle. Before the rocket propellant gets to the nozzle, it is under extremely high pressure and then burn up in the combustion chamber. And it is then that the nozzle converts the huge amount of energy into kinetic energy by accelerating the gas. While doing this, the nozzle can also be gimbaled to control the rocket's trajectory. This will be the most spectacular view during today's test. But remember, we are testing the complete core stage, including the tanks, electrical system, software, sensor, ignition, and more. As you can see, in the upper right corner of the screen, we are about 14 minutes from the H0, when the engine will ignite slightly before. If you are just joining us, we are enjoying live views of the Ariane 6 test model as it stands ready for a last major test before launch. In 13 minutes, 31 seconds, we should see the Vulcain 2.1 engine ignite and fire for about 8 minutes in a rehearsal of the complete Ariane 6 main stage. The countdown clock you can see is counting down to H0, the moment where Ariane 6 will lift off on a normal launch. This is a few seconds after the Vulcain 2 engine ignition. Today, Ariane 6 will stay firmly on the ground, but we are running through all steps of the main stage so that next time we shoot for the start with a launch instead. The weather is always a factor here in French Guiana, and Europe Spaceport as weather station and expert will keep us updated of the weather. Lightning or high ground winds will be a showstopper for this test. But today, all is looking good and the skies are clear, with no concern for the test. Coming up next at H-10 minutes, the Director of Operations and the Launch Campaign Operation Manager will confirm the launch pad and the launcher are ready. If the sequence encounters any anomalies, they will appear in red in the control room monitors. And we refer to them as red status, or rouge in French. Possible reason for a red status can be from the launch pad, the launcher, weather prediction, or come from launch range or safety officer. If a status is red, the launcher system is placed in safeguard or safe waiting configuration, and the countdown is stopped. The countdown clock will then be rewound at H0 - 5 minutes, the pre-synchro again, ready for a new attempt. If you are just joining us, we are broadcasting live from Europe Spaceport, French Guiana, where the Ariane 6 test model is ready for an important test of its complete main stage. In 10 minutes 44, we expect to see the Vulcain 2.1 engine ignite and fire for about 8 minutes. And we have just had confirmed that the Director of Operations and the Launch Campaign Operation Manager have met and confirmed we are go for the ignition of the engine. The next milestone is the start of the synchronized sequence and H-5 minutes. From that -5 minutes mark, the entire checklist process will totally automatic, carried out by ground computers. Here you can see the nozzle of the Vulcain 2.1 engine under the Ariane 6 core stage that is set to ignite just under 7 seconds before the H0. Just igniting this monster in itself is a complicated feat of engineering. When we start to pump the liquid oxygen and hydrogen through the combustion chamber, they will expand and be forced out of the nozzle in a whirlwind of gases mixed to the perfect ratio. This mixture of gases will swirl in all directions. After 4 seconds, we will see stabilization of the whirlwind and in the nozzle, and from then on, we will have a full throttle for 8 minutes. Ariane 6 is an European rocket and a collaboration in a true European style. Today we have many groups of people working on this test, Ariane Group, ESA, and CNES, and 15 companies. ESA's role in the development of Ariane 6 is head of the program. The agency managed that complex program and budget from the member state that contribute to the family of launchers, as well as being in charge of the overall launch system. The 13 participating states in the Ariane 6 program are Austria, Belgium, the Czech Republic, France, Germany, Italy, Ireland, the Netherlands, Norway, Romania, Spain, Sweden, and Switzerland. Ariane Group is lead contractor and design authority for the launcher itself. The company is responsible for the Ariane 6 development and production with its industrial partners. This means that industry across Europe have built that you are seeing today, as well as the future rockets that will fly and its components under the guidance of Ariane Group. Ariane Group's subsidiary, Arianespace, is the operator of the launcher and the launch service provider. The launch pad of Ariane 6 is a completely new project and a huge undertaking in itself. The 1.5 square kilometer pad was built and operated by French Space CNES. At Europe Spaceport, the French Space Agency CNES managed operations, the delivery of the satellites to be launched, monitoring and tracking the rockets during their flight, security, safety of the area, and ensure the local environment is protected. After the first flight of Ariane 6, the commercial exploitation of Ariane 6 will be run by Arianespace, identifying commercial markets for launches, and they will be responsible for the commercial use of Ariane 6. Arianespace is not involved in today's test. Coming at the counter, 6 minutes, -6 and 6 minutes and 9 seconds. Coming at the -5 minutes, we expect the beginning of the synchronized sequence. We are broadcasting live from Europe for the rejoiner, from Europe Spaceport on the edge of the Amazon rainforest here in French Guiana, where an Ariane 6 rocket model sits on the launch pad, awaiting its last major rehearsal needed before its inaugural flight. This test will include the ignition of the launched Vulcain 2.1 engine, which we expect to see about 5 minutes, 19 seconds.
À tous de DDO, attention pour la séquence finale lanceur. Top à 0 moins 5 minutes.
I have had confirmation that the Ariane 6 synchronized sequence had just begun. The launcher itself is now leading the show. It will take decisions for ignition, engine control, and safety. Remember, at 13 seconds before H0, control is handed from the ground system to the onboard computer. From that moment on, we cannot pause the countdown clock and make a new attempt today. From here, things go fast, very fast. This will be the 13-second point of no return, and the engine will then be ignited. Here we see the Jupiter control room at Europe Spaceport in French Guiana. Note all green lights on the left. These show the status is good and the countdown can proceed, what we like to see. The countdown you can see top right is not a simple kitchen timer. It reflects the time left on the schedule until liftoff on a normal launch. The Vulcain 2.1 ignites 6.8 seconds before H0, but the countdown can be stopped automatically when parameters are out of bounds or at the launchpad director's discretion. Unlike real time, this clock can be stopped, paused, and or even put back. The countdown gives personnel a quick glance at where they are in the process.
À tous de DDO, arrêt de la séquence synchro.
Here is the Jupiter control room again, where management sits, and the DDO, the Director of Operation, who says the iconic Allumage Vulcain. We hope to hear soon. The Jupiter 2 room is the Europe Spaceport main control center and used for Vega and Ariane launches. So we just have the clock has stopped. I'm looking for more information to broadcast. The countdown of the hot fire test has been paused, 2 minutes 42 seconds. For those of you who are just joining us, we are broadcasting live from Europe Spaceport in French Guiana, where the Ariane 6 long-duration hot firing test is about to take place. This has been a delay. We are looking for more information for you. For those of you who are just joining us or waiting, we are broadcasting live from Europe's spaceport in French Guiana, where the Ariane 6 long-duration hot firing test is about to take place. There has been a delay. We don't know still. We are waiting for information. During the Ariane 6 synchronized sequence, any technical anomaly encountered on the launcher or launch pad will stop the countdown. We have the countdown stop. We are looking for more information. To communicate. Don't leave. We are coming back soon. Now the launcher system is placed in safe waiting configuration. We are currently awaiting the announcement of a new test time. Please stand by. As soon as the technical issue is solved and the launch system is ready to restart, the chronology again, the operation manager defines a new H0 and the sequence is restarted. We are currently awaiting the announcement of a new time. we do not have this information, so please now follow ESA social media or channel for updates. We will be with you shortly. Thank you. See you. The countdown of the hot fire test has been paused, as you can see, at 2 minutes 42 seconds. For those who are just joining us, we are broadcasting live from Europe Spaceport in French Guiana, where Ariane 6 long duration hot firing test is about to take place. During the Ariane 6 synchronized sequence, any technical anomaly encountered on the launcher or on the launch pad or the launch range will appear and stopped the synchronized sequence. As soon as the technical issue is solved and the launch system is ready to restart the chronology again, the operation managers will define a new H0 and the sequence is restarted. We are still waiting the announcement of a new test time. Please stand by.
In Kourou, the launch pad for Ariane 6 is taking shape. The big hole is already there, the excavation is finished, and the launch zone buildings will soon appear. Ariane 6's launch pad will be different from previous launches in Kourou, with the stages being prepared horizontally. In parallel to these ground activities, the configuration of Ariane 6 is frozen with two possibilities. Ariane 6.2 mainly for single payloads, and Ariane 6.4 for dual payloads. The goal is to ensure Europe secures its independent access to space and continues to play a key role in the worldwide launcher market competition.
The independent access to space is, of course, the primary objective. And we always used European developed launchers to fulfill this objective. We were lucky enough that we were very successful also on the commercial market with Ariane 5 we still have over 50% of the commercial market. As we all know, this environment is exposed to fierce competition. The offer of launch vehicles from 2020 onwards will be significantly higher. And we have designed Ariane 6. We have designed it to cost. We have designed it to be able to go against this fierce competition in 2020 onwards. And for this, of course, we also use this launcher to deploy European flagship programs like Galileo.
So, Ariane 6 should maintain Europe's leadership in the fast-changing commercial launch service market, while responding to the needs of European institutional missions. This move is associated with a change in the governance of the European launcher sector, based on a sharing of responsibility, cost and risk by ESA and the industry. One key factor in this new approach represented by Ariane 6 is the so-called European preference. It means launching European satellites with European launchers. This time it should become a reality with tailored contracts for European institutional customers like governments, ESA, EUMETSAT and of course the European Union.
We built Ariane 6 on the heritage of Ariane 5 mainly. So technically we know exactly where we are going. On the cost side, we diminish by two, by better processes, by using existing technologies, as you know. So in fact, we come on the market with a reliable, hopefully reliable, but a good product at a clear cost. This has to be seen together with the need from the customers. And the customer, we need to deploy today Galileo, and we have an opportunity to match the two together and ensure that Europe flies its own programs with its own launchers.
Ariane 6 will be the workhorse for Galileo, while the upgraded Vega C, will cover the deployment of the Sentinel satellites for the EU's Copernicus program. Vega C will increase Vega's current capacity from 1.5 tons to 2.2 tons on polar orbit, which is the most common orbit for observation satellites. With both Ariane 6 and Vega C, Europe will provide the same services as the current Ariane 5, the Soyuz from CSG and Vega. being able to launch any satellite on any orbit from its spaceport in French Guiana. However, the launcher will be fully European.
We are back with our live coverage of the Ariane 6 hot fire test. I am Tony Dos Santos. He's a technical manager for Europe Spaceport here in Kourou in French Guiana. We had an anomaly during the previous attempt which caused the chronology to stop just before H-2 minutes. From this moment, the Ariane 6 test model was placed in safe waiting configuration. This was a light anomaly concerning transient threshold pressure, which was slightly.
Top à 0-5 minutes.
We have now restarted the synchronized sequence. So this was a light anomaly concerning transient threshold pressure, which was slightly different from our prediction, but it was not blocking for today's test. The team has just performed the correction and the synchronized sequence has been resumed. In fact, this is really the reason why we perform tests, is to lower the risk of an anomaly like this from happening during an inaugural flight. So the operation manager has now defined a new H0, and the sequence, as you can see, has been restarted. For Ariane 6 and for today's rehearsal, H0 refers to actual time of liftoff, so 6 seconds after the main engine ignition. This is slightly different from Ariane 5 launch. It is used to be the time when the main engine was ignited, but the liftoff was a little later. We will not see a launch today, as the boosters will be not ignited, only the core stage engine. Once ignite, it burned through 150 tons of supercooled propellant in just 8 minutes, heating up to 3000 degrees Celsius, other than outer layers of supergiant stars. Today's countdown started yesterday already. We are now 3 minutes away, but teams have been working 10-hour shifts loading the Ariane 6 stage with propellant. The loading was slowly to avoid any thermal shocks in the tanks, fuel lines and pumps. We use liquid oxygen that is super cooled to minus 183 degrees Celsius and liquid hydrogen to minus 253 degrees Celsius, so just 20 degrees from the absolute zero, the coldest temperature possible in the universe. At these temperatures, the liquids are very unstable and want to evaporate in the tropical heat of the Europe spaceport. If you just join us, we are about 2 minutes now away from the ignition of the Vulcan 2.1 engine, the main engine of the Ariane 6 rocket, Europe's next launcher. Today is a test that will qualify the full core stage and the launch pad, the last major full rehearsal needed before launch. Now we wait for the director of the operation to announce the final minute before H0. A reminder that ignition will occur 7 seconds before H0. I will then stop talking from now. Enjoy the test.
À tous aux DDO, attention pour moins 1 minute. Top à 0 moins 1 minute. Attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Allumage Vulcain.
Get ready for the gimbal test. The nozzle is now tilting to test its movement. During a launch, this will compensate for any aerodynamic forces pushing Ariane 6 off course. Small changes made automatically by the rocket's avionics will keep Ariane 6 on course. The Vulcain 2 engine is at maximum temperature, 3000 degrees Celsius. At this temperature, gold will turn into a gas. So we cannot use gold and many other metal in the engine. H0 plus 1 minute 33. We are around plus 2 minutes. If this were a real launch and not a test, we expected booster separation around this point when the rocket reached an altitude of about 70 kilometers. As you can see, for this full-scale core stage, Ariane 6 is staying on Earth as planned. Without the boosters, the Vulcain 2.1 engine provides full thrust, but the nozzle also controls its ascent by moving on a gimbal. Around 3 minutes into the engine firing. If this was a normal launch, Ariane 6 will be at 100 kilometers above Earth now, well on its way into space. The fairing protecting the satellites inside at the top of the launcher would be not useful and now separate, fall away. If you are just joining us, we are broadcasting live from Europe Spaceport in Kourou in French Guiana. We are enjoying live views of the Ariane 6 Vulcain 2.1 engine test. We are currently at plus 3 minutes 48 seconds into this hot fire test. During this test, we rehearsed to understand this complex system, gain experience, and test what is all working as everything is working as it should, of course. Today is the major test. It's also the most visible, with the 8-minute firing of the main engine, which is why we are showing it. For this test, we are not using the launchpad water deluge system that spray an incredible amount of water at high pressure under the rocket. The water is not to put out fire. but to suppress the sound and vibration caused by the boosters. As the boosters are not being tested today, the water deluge system is not needed. We do need to cool the Vulcan 2.1 down during these 8 minutes of this test. Vulcan 2.1 has its own cooling system. For this test, it stays close to the ground. We need to stop the engine from overheating. In a normal launch, the launch pad will only be subjected to 3000 degrees for a few seconds before takeoff. But during this test, it's for 8 minutes. Therefore, we have adapted the water deluge system to provide constant cooling. A system has been installed specifically for this test to cool the flame deflector and the flame trench from the heat. We also installed carbon fiber panels on the flame deflector for the same reason. For the rejoiner, we are broadcasting live from Europe spaceport on the edge of the Amazon rainforest here in French Guiana, where an Ariane 6 rocket model is undergoing its last major rehearsal needed before its inaugural flight. The launcher's Vulcan 2.1 engine was ignited about 6 minutes 37 seconds ago and is still burning.
Tir avorté en cours. Fin de la chronologie CTHF. Succès de ce premier allumage Vulcain.
So we have confirmation, main engine cut off, the Ariane 6 core stage has depleted itself from fuel, and the engine firing of today's test is finished. If it was a launch, Ariane 6 will be in orbit, and the core stage will separate from the upper stage, the orbital stage. I'm so happy to see this moment and share it with you. Now, the teams on the ground will start disarming the launch zone by pumping out the fuel of the upper stage tanks that wasn't fired today's test, of course. We now have many days of analysis in front of us. More than 800 sensors around Ariane 6 have been recording non-stop. We will be comparing the data received in this test to what we expected to happen and see if there is any difference. It generally takes 2 weeks to analyze all the precious data we get. From here, we learn, we gain experience, and we are getting prepared for Europe's newest, mightiest, heaviest rocket. Thank you, thank you, thank you for watching this moment test. Hundreds of people have been working towards this moment, and I'm very happy to have shared that with you. We have just witnessed a complete new rocket firing its main engine and its first full test of the main stage. Thank you. See you next time for a real launch. You might see me in Jupiter control room. I'm Tony Dos Santos for the European Space Agency, wishing you all the best. Bye.